All right, so 11, we're going to solve. And we got 3 sine squared x minus 4 sine x minus 4 is equal to 0. And we're going to do that in the interval. Well, this is actually one part A. We're going to go in the interval from 0 to 360 degrees. Now notice I didn't put 0 to 2 pi, I actually wrote it in degrees. And that's because our answers are going to be in degrees and they're going to be rounded to the nearest hundredth. That's why I specified it this way. So again, this looks like a quadratic, which means we can factor it. So I'm going to go ahead and do my substitution. X equals sine x. And I'm going to go ahead and write that out and take a sip of coffee too. So that gives me 3x squared minus 4x minus 4 is equal to 0. And then when you factor that, you wind up getting 3x plus 2 times x minus 2 is equal to 0. Again, I'm not doing all the work in between to factor it, just to save some time. You can refer back to my videos on factoring. And then here, this would be 3 sine x plus 2, and then sine x minus 2 is equal to 0. So we're going to go ahead and we're going to solve these, set them equal to 0. So 3 sine x plus 2 is equal to 0. Sine x minus 2 is equal to 0. And then I'm going to subtract 2. And I get 3 sine x is equal to negative 2. Divide by 3. And I get sine x is equal to negative 2/3. So that does not look familiar being on the unit circle. So we're going to have to definitely do an inverse to solve for that. Here we're going to add 2. And you get sine x is equal to 2. Now this is always when I would have my students to say, all right, so go ahead and do the inverse to solve for x here. And what happens is you'll wind up getting that it's undefined, because sine, it goes between negative 1 and 1. It's never going to be a 2. So there's no way for that to happen. So if you didn't realize that and you tried to solve it on the calculator by doing the inverse, you would see that it's undefined. That's not actually possible. So here, we're going to do the inverse. Move this up a little bit. So we're going to have x is equal to sine inverse of negative 2/3. And when you do that, you get x is equal to negative 41.81 degrees. Well, what is that giving you? That is giving you the reference angle. Remember, reference angle is always positive. So if you do the inverse and you get a negative acute angle, you can just go ahead and make it positive. So our theta prime, remember theta prime means the reference angle, is equal to 41.81 degrees. So let's look at the signs. I'm going to take that over to here. So where is sine negative? So all students take calculus. Sine is negative in quadrant 3 and it's negative in quadrant 4. So we're going to have this answer here, and then we're going to have this answer here. So we're going to have a Q3, quadrant 3 answer, and we're going to have a Q4, a quadrant 4 answer. Well, remember that our reference angle is 41.81 degrees. So that means that right from here to here, this is 41.81 degrees, and then from here to here is 41.81 degrees. Well, how do we use the reference angle? So for quadrant 3, this from here to here is 180, and then we're going to add the reference angle. So the quadrant 3 answer is 180 degrees plus the reference angle, and that is going to be 221.81 degrees. Quadrant 4, so all the way around is 360, and then if we take away this piece, which is the reference angle, that will give us our quadrant 4 angle. So for quadrant 4, it's 360 degrees minus the reference angle, and that would be 318 0.19 degrees. So the answers for this, it's 221.81 degrees and 318 and 19.19 degrees. So those are our two answers for number 11. All right, so I'm going to take a break here, and then I'm going to pick up with number 12. All right, so number 12, and what you're going to see that this problem is similar to number 11. So you might actually want to try this one, pause the video and try it on your own, and then go back and watch and see how you did. So we're going to solve this in the interval from 0 to 360. Again, they're going to be decimals rounded to the nearest hundredth, which is why we're going from 0 to 360 degrees. So again, this looks like a quadratic. So we're going to go ahead and factor that by doing a substitution first, just in case you need to do that. So x is equal to cosine of x. So that gives us 20x squared minus 11x minus 3 is equal to 0. And of course, you go through the whole factoring technique, which you can look at one of the videos. I'm just going to go to the answer. So when you factor this, you wind up with 5x plus 1 times 4x minus 3 is equal to 0. Now I can go ahead and put back my cosine function. So this is going to be 5 cosine x plus 1 times 4 cosine x minus 3 is equal to 0. Then I'm going to set these equal to 0 and solve them. So I get 5 cosine x plus 1 is equal to 0. 4 cosine x minus 3 is equal to 0. So here, subtract 1. So 5 cosine x is equal to negative 1. Divide by 5. So cosine x is equal to negative 1/5. And that's good. Negative 1/5 is between negative 1 and 1, so we're going to get values for that. And then here, we're going to add 3. So 4 cosine x is equal to 3. Divide by 4. So cosine x is equal to 3/4. Again, that's good. It's between negative 1 and 1, so we're going to get some answers for that. So at this point, we're going to go ahead and do the inverse of both of these. So if I do the inverse, so I get x is equal to cosine inverse of negative 1/5. When you do that, you're going to get x is equal to 101.54 degrees. Now, what is that giving you? That's giving you a quadrant 2 angle. Because if you think about cosine, all students take calculus. Where is cosine negative? Cosine is negative here, and it's negative here. So the 101.54 is actually giving you one of your answers, the 101.54, which is quadrant 2. We need the quadrant 3 answer right here. Well, how do I use this to get that? Well, remember your reference angle goes from here to here. That is the reference angle. So if my theta prime for this would be 180 minus my quadrant 2 angle will give me this piece, which is theta prime. So 180 minus 101.54 degrees, and that's going to equal 78.47 degrees. So that is my theta prime, which is this piece right here. So that means this is 78.47, this piece from here to here. So then my quadrant 3 answer for this would be my quadrant 2, that by doing the inverse already found that for you. That piece was easy. So my quadrant 3 here, that's going to be 180 plus the reference angle, 78.47 degrees, and that is going to equal 258.47 degrees. Go up a little bit. So these are the two answers right here for cosine of x equal to negative 1/5. So now on this side, cosine of x equal to 3/4, when you do the inverse, so x equals cosine inverse of 3/4, that gives me x is equal to 41.41 degrees. Well, that's convenient because that's already theta prime. It's a positive acute angle. So theta prime, my reference angle, is 41.41 degrees. Now, if you think about when is cosine positive, all students take calculus, it's in quadrant 1 and in quadrant 4. Well, this already gave me the quadrant 1 answer. This is 41.41 degrees. So I already have my Q1 angle. To get my Q4, that piece right here is 41.41, my reference angle. So it's going to be 360 minus the reference angle. So that's going to be 360 minus 41.41 degrees. And that is going to equal 318.59 degrees. So what we have here for the cosine x equals negative 1/5, our quadrant 2, Q2 angle, is 101.54. That you got when you actually did the inverse. It gave you that answer. We used that to find our reference angle, which is theta prime. So if you're in quadrant 2, it's 180 minus the 101.54 gives you your reference angle, which was 78.47. Then we use that to find our Q3 angle. So 180 plus the reference angle gave you our Q3. So that was those two. Over here, we went ahead and did the inverse, and that gave us 41.41. Now that was actually worked out great because we're already in quadrant 1 because cosine's positive in 1 and 4. So we already have our Q1, and it's also our reference angle, our theta prime. So then the quadrant 4 answer is 360 all the way around minus the reference angle, and that gave us a 318.59. So all we really have to do is just state, so x is equal to, and we have 41.41 degrees, 101.53 degrees, and this would be 258.47 degrees, and 318.59 degrees. And actually this was rounded, this is 101.54, sorry about that. So 41.41 degrees, 101.54, 258.47, and then 318.59. And that one is finished. And we'll pick up with number 13 in part 5.